It's our nearest planetary neighbour in the solar system and has always seemed temptingly inhabitable. Then in the 1970s, a series of space probes revealed that it did indeed contain the one essential ingredient that makes life possible.
What we've learned from studying Mars, both from the Earth and with spacecraft, can really be summarized, I think, in the concept water. We've learned that early in its history, Mars had lots of water, rivers, lakes, maybe even oceans. We've learned that it's now cold and the water is frozen, but that the water is still there, frozen into the ground. So water, water, water. That's what we've learned about Mars. Well, water, of course, ties to life. So I think that water, water, water on Mars turns into life, life, life on Mars.
For scientists like Davis, this opens specially exciting possibilities. Because if that life exists, it could have started while the Earth was still uninhabitable. Mars is smaller than Earth, and back in the early days of the solar system, when the planets were still molten, it would have cooled more rapidly. What's more, the record of that early life might still be there. Mars, like the Moon, has remained geologically undisturbed for much of its existence. But in the early 1990s, few people took seriously the idea that Mars might have something important to tell us about early life.
Today, Mars is a freeze-dried desert and pretty inhospitable for life. But in the early days, it was warm and wet and actually probably more favourable than the Earth. I think I was one of just a small number of people, a voice in the wilderness, if you like, thinking that we should take life on Mars seriously. Time and again, I tried to tell newspapers and TV channels that this was a really important story, and nobody wanted to know. They either thought the story was boring and irrelevant or completely unbelievable.
The problem was a total lack of evidence of any life on Mars. Then there was an important discovery. Scientists found that fragments of previously unidentified meteorites scattered across the surface of the Earth contained small bubbles of gas with an identical chemical composition to rocks analyzed by the space probes on Mars. They were tiny Martian meteorites, blasted off the planet by cosmic collisions in the distant past and trapped by the Earth's gravitational pull. A new avenue for investigating Mars had opened up.
Here on the surface of the Earth, we've now identified a couple of dozen Mars meteorites. But hey, I'm telling you, there are thousands of them around. We know they're there, it's just a matter of identifying them. I guarantee you that within a mile of where we're sat, there's at least one Mars meteorite. It's sat in a field out there. We don't necessarily know which rock it is of the myriad rocks which are there, but we know it's there.
Davis has been a frequent visitor to the lab in Australia where one of these meteorites is kept. He's suspected for some time that one of these Martian fragments might contain important clues.
And what's the story on this particular rock? When did this fall?
It's called Cradle. It fell in Egypt years and years ago.
Nobody knew it came from Mars at that stage?
No, at that stage it was totally unknown. It was just a meteorite of a very peculiar type. And only later was this peculiar group of meteorites found to have come either from the Moon or from Mars. The strange thing about it, of course, the Cradle is renowned for having killed a dog.
the only example of a canine fatality from a cosmic object.
Yes, yes.
The full significance and value of pieces of rock like this that come from Mars has dawned on scientists only slowly. It's really only in the last few years that they've been kept very carefully under lock and key. In fact, this very piece of rock here was lent to me by Vic Gostin a number of times, and I used to carry it around in my pocket. I once pulled it out of my pocket in a pub. I'd forgotten it was actually there. I'd gone for a drink in London with my brother, and we sat there in the pub, and I said, well, look, this is my round, and I put my hand in my pocket for the change, and of course discovered this piece of Mars. And I said, oh, you might be interested in taking a look at this, you know, it comes from Mars. And he was clearly disbelieving, and he said, oh, well, I've heard this story before. I met a man in a pub and he tried to sell me a piece of Mars. In one sense, it's worthless. On the other hand, it is, in a sense, priceless. How could one put a value on a piece of rock that comes from another planet? To recover a piece like this for yourself by going to Mars, bringing a rock back in a spacecraft would cost you tens of billions of dollars.
Yet Davis's conviction that Mars might harbour important evidence of early life forms continued to fall on deaf ears.
There was an occasion when I had a TV film crew visited me at my office, and I used this very piece of rock to illustrate the point that Mars rocks are right here on Earth and that they could bring microorganisms here. And there were sort of polite nods, and away they went, and a few months later the program was shown on television. I didn't appear. They decided to cut that stuff out. It was really unbelievable.
All this changed in 1996. A small meteorite discovered 20 years before in the Allen Hills area of Antarctica was found to be from Mars. And it appeared to contain convincing evidence of life. The so-called Allen Hills meteorite caused a sensation.
If this discovery is confirmed, it will surely be one of the most stunning insights into our universe that science has ever uncovered. Its implications are as far-reaching and awe-inspiring as can be imagined.
It was an historic moment and seemed to vindicate everything Davis had been saying. Suddenly, the idea of life on Mars was a serious scientific possibility. Or was it? One of the scientists to examine the evidence was Professor Richard Zare.
What we saw were complex organic molecules. On top of that, there was evidence of interesting mineral formation, small pieces of magnetic iron oxide called magnetite. Well, bacteria have magnetite. It's even thought that maybe some humans have magnetite in their brain as well. And lots of living forms use little bits of magnetism to navigate. Bees do it, birds do it, and maybe this magnetite comes from something that lived before. It led our team to put forward a hypothesis that we had evidence of some relic form of primitive life in ancient Mars. And then what excitement there was.
Zare says his findings were never more than a tentative hypothesis, but the media circus was already underway.
It's an unbelievable day. It's very, very exciting for me, and I hope you feel the same excitement that I feel. First, I want to congratulate the team members who brought these exciting results to the American public and the people of the world.
When this story hit the headlines, we were deluged with telephone calls and interviews and people who wanted to discuss this. There were people who were certain one way or another what this meant. I wasn't certain, but there were lots of people who were certain.
Is life unique to planet Earth?
Despite the widespread publicity, to this day, Zare is still puzzling over what he actually saw in the Allen Hills meteorite, and whether it really was an indicator of life.
My feelings about the Allen Hills meteorite is that the jury is still out. Perhaps will always be out. Part of the whole problem is we don't understand how life ever came about on Earth. And that's what's frustrating in this search. My own conclusion, when I look back on this, is that we can find the answer to this question. It's a scientific question, whether or not there was life on early Mars. But the way to do it is to go to Mars.
The evidence that Davis needed to develop his ideas continued to elude him. Yet the excitement generated by the Allen Hills discovery has put Mars today at the top of the space agenda.
The episode has served to focus attention on the possibility of life on Mars, the possibility that it could be transferred to Earth in a meteorite, and whatever the final outcome of that particular episode, it has meant that new projects have been planned to seek out life on Mars.
One of the places where this planning has been coordinated is the Mars Mission Control Center in Denver, Colorado.
Standing by for a transmitter to come on at the station.
Here they're gearing up for a new assault on the planet later this year. Among its principal tasks will be the search for traces of life. On a recent visit to America, Davis went to see what was going on.
Where's the best place on Mars to look for signs of life, do you think?
Well, ever since Viking, we've been thinking you really need to find an oasis. If you could find a place where the water comes to the surface, that's the best outcome.
So you might want to look in the regions of the polar caps.
Well, it's very interesting. The polar caps are even colder than the equatorial regions of Mars, but the sunlight can be very strong in the summertime. So you could have times during the polar summer when the environments became very favorable for life.
The great thing about Mars is very little has changed in 3.5 billion years. So if there was life on Mars, say 4 or even 4.2 or 4.3 billion years ago, it's entirely possible that rocks dating from that period are still there on the surface for us to find, containing a record of life that stretches back well before any sort of life on Earth.
Could one of these ancient rocks hold the final clue to the riddle of life? If, as Davis believes, the earliest life forms existed in hot subterranean environments, and if they could live without most of the commonly assumed prerequisites of life, then around 4 billion years ago, there was nowhere better for life than Mars. The jigsaw of pieces was pushing Davis to a new and even more controversial conclusion. At the Mars Mission Control Center, he once again entrusts his thoughts to his video diary.
I just spent an absolutely fascinating day at Mars Mission Control, and I've come over here to the rocket factory to see for myself the boosters. If we ever do find evidence for life on Mars, it'll be rockets like these that will be sending the package of equipment there. I've often thought that Mars was a better place for life to get started than on Earth, and there could have been life on Mars long before it was here on Earth. And that raises the possibility that maybe it spread from Mars to Earth, in which case we'd all be descended from Martians, which is certainly quite a thought.
It's a fantastic notion. Could it really be that life started on Mars while the Earth was still too hot?
The idea that life came to Earth from Mars, I think most people regard as totally absurd, as some sort of joke. After all, it's been a science fiction theme for many years, a very favourite one, but that's the way most people think of it, as just plain fiction. But what I'm saying is that we have to take that possibility seriously as science fact.
It's not an idea Davis has found easy to sell.
This is not what we would normally consider a standard of scientific proof of anything, is it?
No, nobody's talking about proof.
It's like trying to find intelligence in steak tartare. It's a pointless activity.